11.7, the counting principle in permutations. So I'm recording this in my office. If you hear things, it's the hallway outside. So counting principle, we've already talked about this. If a first experiment can be performed in m distinct ways and a second experiment can be performed in n distinct ways, then two experiments in the specific order can be performed m times n distinct ways. Example 1. A password used to gain access to a computer account is to consist of 2 lowercase letters followed by 4 digits. Determine how many different passwords are possible if repetition of letters and digits is permitted. So that means we can reuse letters. So if we want to use A, we can do that. So for part A, our password must have 2 lowercase letters. So letter, and 4 digits. So digit, 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 digit. How many letters do we have to choose from the alphabet? We have 26. How many digits do we have to choose from? We have 10. So with replacement, that means if I use a letter, I can reuse it. So if I choose a letter, I have 26 letters to choose from. I have another 26 letters to choose from. My digits, I have 10 for each of them. So 26 times 26 times 10 times 10 times 10 times 10, we have 6,760,000 different ways to write this password. So we have just a little bit over 6.5 million ways to create this password. That's why they have you use digits and letters, because it creates so many different ways. Alright, part B. How many different possible passwords are how many passwords are possible if repetition of letters and digits is not permitted? So the password rules didn't change. We're still doing 2 letters and 4 digits. Our first, so without replacement, so repetition is not permitted. So the first letter we pick, we have 26 of them. If we pick one of those letters, we're left with 25. Now we have 10 digits to pick from. If we pick one of those, we're left with 9. If we pick another digit, we're left with 8. If we pick another digit, we're left with 7. So 26 times 25 times 10 times 9 times 8 times 7 is 3,276,000 different possible passwords. Part C. The first letter must be a vowel, A, E, I, O, or U. And the first digit cannot be a 0. Repetition of letters and digits is not permitted. So the rules of the password didn't change. We still need 2 letters and 4 digits. Now it states that the first letter must be a vowel. So the first letter, let's just say it's A. It's A. So if we choose A, how many letters do we have to pick from? 25. So for the digits, it says the first one cannot be 0. So any number other than 0, let's just say 9. That's not a 0. So if we choose the digit 9, we're left with 8 times 7 times 6. So that's 25 times 9 times 8 times 7 times 6, which is 567,000 different ways to write our password. I put B twice. That's part B. My bad. Alright, example 2. At Old Navy, a supply of solid color t-shirts has just been received. The shirts come in green, blue, white, yellow, and red. The floor manager decided to display one of each color shirt in a row on the shelf. In how many different ways can he display the 5 different color shirts on the shelf? So we have how many colors? 5. Green, blue, white, yellow, red. So we have 1 times 2 times 3 times 4 times 5. That's every single color. And that comes out to 120 different ways. So this manager can display his shirts 120 different ways. Part B, if he wants to place the blue shirt in the middle, and how many different ways can he arrange the shirts? So we have 5 shirts to choose from. He wants the middle one to be blue. So if that one's blue, I have 4 shirts to pick from, then 3, then 2, then 1. So 4 times 3 times 2 times 1, we get 24 distinct ways. So if he wants to put blue in the middle, we can only do 24 different variations with blue in the middle. Part C, if he wants the white shirts to be first and the blue shirt to be last, how many different ways can he arrange the shirts? So same thing, we have 5 shirts. Our first one needs to be white. Our last one must be blue. So that's 2 shirts already used. We're left with 3, then 2, then 1. So 3 times 2 times 1, we get 6 different ways. Permutation, so that's what we've been doing. It's called permutation, is an any ordered arrangement of a given set of objects. So it doesn't matter what order it is, just multiply everything together. So number of permutations, if you have 9 with an exclamation point, that's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So in how many different ways can 7 different cars be arranged to next to one another? So we have 7 different cars. The permutation of 7 is 7 times 6 times 5 times 4 times 3 times 2 times 1. So 7 times 6 times 5 times 3 times 2 times 1 is 5,040. So if we have 7 different cars and we want to arrange them together, there's a little over 5,000 ways that we can do that. Consider the 5 letters A, B, C, D, and E, and how many distinct ways can 3 letters be selected and arranged if repetition is not allowed? So we want 3 picks, because it says 3 letters. How many letters do we have to pick from? 5. If we choose one, we're left with 4. Then we're left with 3, because it says repetition is not allowed. So 5 times 4 times 3 is 60. You can arrange 3 of those letters 60 different ways. Permutation formula. The number of permutations possible when R objects are selected from N objects is found by the permutation formula. So we use this if very similar to example 4, where we only want 3 out of the 5 letters. So example 5, you are among 9 people forming an astronomy club. Collectively, you decide to put each other's names in a hat to randomly select a president, a vice president, and a secretary. How many different arrangements of permutations of officers are possible? So we're using our formula. N is the total. R is how many are you picking? So for our example 5, we have 9 people who form this club. Our N is 9. How many names are they pulling out of the hat? Well, they're picking a president, that's 1. A vice president is 2. A secretary is 3. So they're picking 3 people. We plug it into the formula. We have P, my bad, wrong color. P, N, which is 9, R, which is 3, equals 9, the permutation of 9 over 9 minus 3, that permutation. The left side doesn't matter, so we have the permutation of 9 over the permutation of 6, which is 9 times 5 times 4 times 3 times, oh, my bad, messed that up, I was doing 6. 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and 6. 5, 4, 3, 2, 1. We are allowed to cancel everything out. So 6 and down. So 9 times 8 times 7. We get 504 distinct ways. So if we choose, or we put all these 9 people in a hat, we can pull and pick and choose and create 504 different variations. Example 6, the Prince George Country Club, or County Bike Club has 10 different members. wish to travel exactly one. Let me start that over. The Prince George County Bike Club has 10 different routes members wish to travel exactly once, but they have only 6 specific dates for their trips. And how many ways can the different routes be assigned to the dates scheduled to their trips? So our total is 10 routes. That is our N. Out of those routes, we can only pick 6 of them because we have 6 days. Our R is 6. We're going to plug it into our formula. We have 10. The permutation of that, 6 equals 10 over 10 minus 6. So we have the permutation of 10 over the permutation of 4. So that's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 4 times 3 times 2 times 1. We cancel out everything. 4, 3, 2, 1. So 10 times 9 times 8 times 7 times 6 times 5. We get 151,200 different ways. So they have 150,000 ways that they can plan this trip. That's what we're meaning here. Permutations of duplicate objects. So the number of distinct permutations of n objects, where n1 of the objects are identical, n2 of the objects are identical, and so on. So of the objects are identical is found by the formula. So if you have identical things happening, so in how many many different ways can the letters of the word Cincinnati be arranged? So for Cincinnati, let's look at the repeating letters. Total, we have 10 letters in the word Cincinnati. Out of those letters, we have 3 I's, we have 3 N's, and we have 2 C's. So on top is the total. On bottom, we do the repeating ones. We do the repeating letters that we have. So we have the permutation of 3 because there's 3 I's, the permutation of 3 again because there's 3 N's, and the permutation of 2 because there's 2 C's. So 10 times 9, 8 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1. That's the first one. Our second one, we have 3 times 2 times 1. Our last one, we have 2 times 1. You notice I'm not combining anything. I didn't combine 3, 3, and 2. I left it by itself because they're separate entities. We are allowed to cancel out, though. We can cancel out 3, 2, 1, 3, 2, 1 on top. We can also cancel out 6 because 3 times 2, that's 6. We can also, we'll just leave it there. We'll leave it there. So 10 times 9 times 8 times 7 times 5 times 4 all over 2 is 50,400.